Let's look at this problem at 25 degrees. In solutions of equal volume, let's calculate the ratio of hydrogen ion concentrations from water ionization. This is very common. This should be a core concept of this section, hydrogen ions or OH from water ionization. Let's analyze them separately. The first one, T, is a sulfuric acid solution equal to 0. Note this is an acidic solution. We look at hydrogen ions from water. Pay attention to this point. The proof has a key concept. In any solution, hydrogen ions from water and hydroxide ions from water are equal. So hydrogen ions from water ionization should equal hydroxide ions from water ionization. No problem. Now let's analyze further acid solution hydrogen ions. Where do solution hydrogen ions come from? From sulfuric acid, anywhere else? Also from water, very minimal. Looking at the source, hydrogen ions in sulfuric acid come from the acid, mostly from water, a very small portion. Where do hydroxide ions come from? From water, very important, since acid itself cannot ionize. Oh, all hydroxide ions come from water. This equals the hydroxide in solution. This is the key to the proof. How to calculate hydroxide in solution. Use kW. Very good friends, pay attention. The critical concept in this lesson is Kw water's ion product. It equals the product of hydrogen ion and hydroxide ion concentrations. I need hydroxide. You must think to use water's ion constant, divided by hydrogen ion concentration. Water's ion constant is 100x10 circumflex 14. The key is how to find hydrogen ions. We have pH, You can calculate directly. pH equals 0, hydrogen ion equals 1. That's 1x10 circumflex 0. Divide by 1 and you're done. The final result should equal 1x10 circumflex 14. Nothing left. Let's see. The second is basic solution. For basic solution, same logic. First, hydrogen ions from water should equal hydroxide ions from water ionization. That's not an issue. What's the key? The key is analyzing the basic solution. Where do hydrogen ions come from? Where do hydroxide ions come from? Where do hydrogen ions come from? From water. So actually you don't need to write this. You can skip writing this note. That hydrogen ions from water are all the hydrogen ions in solution. Actually, it's simpler if you cover it. It directly equals it. Then how to calculate it equals Kw divided by hydroxide, very similar to above. I calculate hydroxide this way. I can calculate hydrogen ions the same way, equal to Kw compared to hydroxide ions in solution. Now these hydroxide ions originally should mostly come from salt, a small part from water. When we calculate, we should assume, or when calculating, let hydroxide ions in solution roughly equal to hydroxide from salt. That's actually enough. When calculating, we can all do it this way. Finally, it should be 1 times 10 to the minus 14 power. Then compared to multiply this by 2, and that's it, compared to 0.1. Answer should equal 1 times 10 to minus 13 power. Not quite right. This is the second one. Third note 3 and 4 are important and more difficult. Both are salts. I must emphasize, both are salts, and both are positive salts. They cannot produce hydrogen ions or hydroxide in solution. All hydrogen ions and hydroxide, where do they come from? From water. They all come from water. Then you think, what property does this solution show? Basic property, good. Basic property. Hydroxide ions should be more abundant. Where do hydroxides in solution come from? From water, That's water ionization producing hydroxide, and we said from water, hydroxide produced by water ionization equals hydrogen ions produced by water ionization. This word is now listed. Then what I need to calculate is calculate it simply Kw divided by hydrogen ions, right? Then continuing, I'll write next equals Kw over hydrogen ions. Kw equals 1 times 10 to minus 14. Hydrogen ions should be 10 to minus 10. Result equals 1 times 10 to minus 4 power. Correct, I've got it. These hydrogen ions from water should equal this number. Good. Finally, circle 4. Circle 4 is an acidic salt solution. This solution has more hydrogen ions. I'm using the same logic. More hydrogen ions. All hydrogen ions come from water. Right? I don't need to write hydroxide. Everyone knows their equivalent. How to calculate. It equals Kw, right? It directly gives the Kw value. I can use it to find hydrogen ions in solution 1 times 10 to minus 5 power. And that's it. You can see these two approaches differ. Note for acid and base solutions, we must use the smaller quantity to calculate, for example, hydroxide in acid or hydrogen ions in base. Use the smaller quantity because they both suppress water ionization. While these two promote water ionization, we should ultimately use the larger quantity, that is the hydroxide here and the hydrogen ions here for calculation. The approaches differ. Finally, comparing these values 10 to minus 14 versus 10 to minus 13 versus 10 to minus 4 versus 10 to minus 5, the answer should be B, definitely B good. This question has some difficulty, and it's commonly tested. Calculating hydrogen ions or hydroxide produced by water ionization. Let me summarize this method for everyone. I hope you master this well. Just understand the logic.